Hi friends, I'm Mohammad Usman. Now we are going to see about system calls in operating system and in-depth analysis. First, these are our topics: introduction to system calls. This is our first topic. Categories to system calls are second. System call implementation is our third. Performance considerations, security and system calls, case studies, future trends in system calls, and conclusion. Introduction to system calls. Role, definition and purpose of system call. Role in OS architecture. System calls act as a bridge between user application and the operating system kernel, providing a controlled interface for executing privileged operations on hardware. Types of system calls. System calls can be categorized into various types, including process control, file management, device management, information maintenance, and communication, each serving specific functions within the OS. Importance of system calls. Abstraction layer. System calls provide a significant abstraction layer, enabling application developers to access hardware resources without needing to understand their complexities or underlying implementations. Resource management. System calls plays a crucial role in resource management by coordinating and allocating system resources efficiently among concurrent processes to ensure optimal performance and stability. Categories of system call. Process control, creation and termination. Process control system calls enable a program to create a new process and manage their execution. This includes the allocation of resources and the termination of processes when they are no longer needed. Scheduling and synchronization. Scheduling and synchronization calls manage the execution order of processes to optimize CPU usage. They also handle inter-process communication and coordination between concurrent processes to avoid conflicts. File manipulation. There are several operations occur here. They are open, close, read, write. The system calls manage files by allowing programs to open files for reading or writing, close files when operations are completed, and read data from and or write data to the files. Files permissions and attributes. File manipulation system calls also handle permissions and attributes, enabling programs to modify access rights, change ownership, and adjust file characteristics such as timestamps and file size. Device management. Device drivers. Device management includes system calls that interact with device drivers, which acts as intermediaries between operating system and hardware devices, facilitating communication and control. I/O operations. I/O operation system calls manage input and output processes, allowing programs to send and receive data to and from peripheral devices, ensuring consistent and efficient data transfer. System call implementation. System call interface. Application programmer's interface, that is API. The API serves as the gateway for applications to communicate with the operating systems, providing a set of predefined functions that abstract complex system calls into simple, manageable requests. System call numbers. System call numbers uniquely identify each system call, enabling efficient access and control within the operating system. A defined mapping between numbers and their corresponding functions is crucial for system reliability. Context switching. User mode to kernel mode. The transition from user mode to kernel mode occurs during system calls or interrupts, allowing the operating system to gain control and execute privileged operations safely on behalf of user processes. Stack management. Stack management during context switching involves saving the current state of the process, including registers and stack information, ensuring that process can resume execution accurately and seamlessly after being swapped out. Performance considerations. Overhead of system calls, latency and throughput. System calls often introduce latency due to context switching between user mode and kernel mode. Understanding their impact on throughput is essential for optimizing application performance. Minimizing system call frequency. Reducing the frequency of system calls can significantly enhance performance. Grouping operations or using higher level APIs can decrease the overhead associated with each call. Optimization techniques. Catching system call results. Implementing a caching strategy for frequently accessed data can reduce the need for repeated system calls, improving overall efficiency and application responsiveness. Batching processing system calls. Batch processing allows multiple system calls to be handled in a single operation, reducing the context switch overhead and enhancing performance through aggregated processing. Security and system calls. Access controls. User permission. The user needs the permission. User permission defines what actions users can perform on a system based on their assigned rights, ensuring sensitive data is protected from unauthorized access. Role-based access control. RBAC role-based access control assigns permissions to user based on their role within an organization, simplifying management and enhancing security by limiting access to necessary resources. Vulnerabilities, injection attacks and denial of service attacks will happen in vulnerabilities of system calls. Injection attacks. Injection attacks occur when an attacker sends untrusted data to an interpreter, allowing malicious commands to be executed, potentially compromising the system's integrity. Denial of service attacks. Denial of service DOS attacks overwhelm a system's resources, making it unavailable to legitimate users, which can result in significant downtime and loss of reputation. Case studies. Linux system calls. Common system calls in Linux. Common system calls in Linux include open, close, read, write, and execute. For open, it will occur open operation to open a file, and close, it will close a file, that's the operation. Read, it will read the data in the file. Write, we can overwrite the file or we can write the new file, and execute a file. These calls allow user application to interact with the kernel for file operations, process management, and more. Kernel modules and system calls. Kernel modules extend the functionality of the Linux kernel and they can introduce new system calls. They provide a way to dynamically add features without rebooting the system, enhancing modularity. Windows system calls. Windows API and system calls. The Windows API includes a variety of system calls that allow applicants to perform operations like file management and network communication tightly integrated with Windows architecture. Comparing Linux and Windows. This section discusses the difference in system call management and implementation between Linux and Windows, highlighting performance, security, and design philosophies. Future trends in system calls. Evolving operating systems, microkernel architectures. Microkernel architectures focus on minimalistic design where only essential services run in kernel mode, resulting in enhanced security, modularity, and easier system maintenance. Containerization and system calls. Containerization technology encapsulates applications with their dependencies, leading to new approach in system calls that require efficient handling of resources and enhanced isolation between environments. Advanced in system call techniques. Asynchronous system calls. Asynchronous system calls allow non-blocking requests, improving application performance and resource utilization by enabling concurrent execution while waiting for I/O operations to complete. Visualization impacts. Visualization affects system calls by introducing hypervisors that manage multiple operating systems on a single hardware platform, leading to unique challenges in system call handling and optimization for performance. Conclusion. Summary of key points. Key finding 1, key finding 2. This section highlights the most significant findings from the research and emphasizing their impact on the field and providing a recap of studies, objectives, and methodologies. A reflection on the implications of the results, discussing how these key findings contribute to existing knowledge and influence practical application in relevant sectors. Thank you.